everyone. Thanks for the introduction, and I welcome you all again here in the second session of FDP here on blockchain technology. Um I'll rush through the few slides and deliberate on few. While I was there in the morning session of Dr. Ashok Kumar Das, I am purview to what has already been covered, so I will not deliberate on those topics. And for audience retention, basically, this is around 3 hours. So I have kept the slides little graphic so that the retention is attained. And the questions may please be posted in the chat window that I'll be able to take on at the end. And being an FDP here with multiple speakers on the same topic, please bear in case I repeat some topics. And it can be taken as a revision for those who missed out for any reason. And I may be just doing the same topic in a different manner. So any sufficiently advanced technology is indistinguishable from magic. And life is simple, and so is blockchain and Bitcoin forensics. Every technology, I feel, is very simple, provided we assert ourselves, we dedicate ourselves to understanding and then implement. For the next few hours, just scribble and think. Just this is not a class. We can be interactive in between or at the end as the coordinator permits. I'll not, since I'll be more or less speaking on the cryptocurrency part, Bitcoin. So I will just at the start, I would say that I'll not be including any investment advices. The focus will be majorly on the technology internals of how the Bitcoin blockchain peculiarly works. So purpose of today's webinar is, of course, we all know acquaint you of blockchain technology, which you already must be acquaint you more on the Bitcoin technology part. So we'll cover the Bitcoin blockchain foundation basics, backend workings, what is exactly happening behind the Bitcoin blockchain. Then this will be all intermittently interspersed with the demonstrations and few simulations. And then at the later part, maybe at the half session onwards, we'll discuss the Bitcoin crimes and forensics. And the most important part, the purpose of today's webinar that I take here is not to bombard you with technology terms and definitions. The purpose is to understand, revise if you already have, and just take on the concept and try and work out in our respective organizations and universities. So the webinar, this webinar and talk basically will give you concept tangents, and I'll be touching upon so many things, and I'll not be able to cover them, of course, because of the peculiarity of time and short. So you can take those on and explore further, and there is no end. So of course, this question I should not be asking since it is a blockchain FDP. So I'm sure there will not be any audience here, any listeners here who have not heard this term Bitcoin. Now, one line definition, one line difference of how we relate Bitcoin and blockchain. Is Bitcoin a blockchain or is blockchain a Bitcoin? So what is the relation between? So in the most simplest terms, Bitcoin is an application of blockchain technology. Just like Microsoft Word runs on operating systems like Windows, any version of Windows, there are ways and means, of course, to run it on Linux also. But basically, it is an application which is running on an operating system. And similarly, Bitcoin is an application which runs on the blockchain technology. More we'll be able to get clear as we move ahead. So blockchain technology has been driving Bitcoin since 2009 non-stop. These next few slides I'll just cover up because I'm sure these all you would be already aware. Purpose of Bitcoin. Everyone has his own views and interpretations. Investors, they feel how to be rich. Technologists, they find a lot of technology inside it. The common man, of course, common man feels this is a way to get rich. Multinational corporations see this as the future. The government of India has, of course, given out varied views over the years. A few of his, like Bitcoin is not a legal tender in India. Blockchain is. Supreme Court prods government on Bitcoin regulations. Indian government loves blockchain, but it wants to kill Bitcoin. These all clips basically I've taken from newspapers pertaining to blockchain and Bitcoin. Like Prime Minister Modi has been more assertive on this technology, on implementation and usage and exploitation of AI and blockchain in agriculture. In various forums, he has been speaking about this technology. And coming from a man of his stature, who has been pushing digital India vision, so this definitely makes the technology very interesting and very futuristic in demand. So, but the general view, the perception that commonly lies is Bitcoin. That means Bitcoin as related to crimes, cyber crimes. So it only facilitates cyber crimes, and Bitcoin are not legal. Is not a legal tender in India. But the fact is that whatever transactions across the world, the Bitcoins are currently happening, only about 10% of them are attributed to crime, as per the Drug Enforcement Agency in US. That's a stat from about 2018. So actual intent of Bitcoin is, this is a definition, which I'll make it more simple. Cryptocurrency is an attempt to bring back a decentralized currency of people, one that is not subject to inflationary moves by a central bank. Now let's make it more simple. What does this mean? Because every word in the ahead slides and in the present slides, every red word that I have highlighted has got a weight behind it, which I'll not be explaining much, but it is just a focus word. Basically, the purpose is no government or other intervention between a transaction which happens between a buyer and a seller. No third-party vendors should be able to do any kind of surveillance between these transactions. In case I'm buying something online, in case I'm doing some transaction, nobody else should be aware other than the seller or the buyer, other than the two parties who are doing the transaction. So what did blockchain technology achieve in this? Blockchain technology basically removed the middleman. At the onset in 2009, basically the Bitcoin, when it was launched, the purpose was negate the middleman, that is the banks or the governments or any kind of surveillance agency which was inside. So let's take example of banks, which can be easily and commonly understood. So purpose of bank, there are so many purposes, methods of payment, offers, interest, loans, business, etc. Now, the basic idea between a buyer and a seller is they associate with the bank for trust. In case they transfer some money, they expect and they trust the bank that that amount of money or that amount of transaction that they have committed with the other guy, it will be honored. So if this trust by the bank is replaced with an algorithm, so that is blockchain. So I'll repeat the word. If this trust by the bank is replaced with an algorithm, it is known as the blockchain. Now, a brief history about Bitcoin. It did not suddenly happen in 2008 by one Satoshi Nakamoto, but it had a history of it. And I'll just take about under a minute. 1982, David Chaum, a computer scientist. Now he is a cryptographer. He given this paper, and he used and introduced a concept of blind signatures to build untraceable digital currency. That's where it somehow started, that there can be something known as e-currency. But the limitation was that the bank had to keep track of all the used serial numbers of whatever he had given as a concept. Now, when the bank had to keep track, so basically the bank always remained. After about 6-7 years more, again the same the cryptographer, he again introduced the revised version of that same paper, and he enabled it with some private identification and some private messaging that can be given in the transactions. Another few years later in Adam Back, now this was happening somewhere else in other corner of the world. Now he introduced a concept known as hash cash. Now hash cash relates to negating the spam part. The idea was that in 90s, when email was just evolving and email was just spreading, like spam had already entered. Spam was kind of a unremovable part of the email domain. So how can we reduce that spam? So Adam Back had come up with a concept known as proof of work for this removing the spam part. Now he says, whenever I send an email to another guy, I'll be sending an email maybe to 1, 2, 3, 4, 5, maybe or 5 or 10 listies. But then to avoid spam, he came up with a concept that I will need to do a computational work to send that mail and legitimize my email. Only then it will be sent. So that was further taken on by V. Day, another computer engineer. He used it. He used the concept of proof of work to create money. Now, proof of work we'll discuss at length, but just a prelude, these four major events had taken place till 2008. Now, in 2008, the magic happened. The cultural change in the technology world happened. How Bitcoin evolved, I'll take another 5 minutes on this. How it all started. We all aware of 2008, the financial crisis which had emerged. Now, the financial crisis which emerged around July 2008. Now, this was followed up by one paper, Bitcoin, a peer-to-peer electronic cash system. Now, this is a 9-page paper which emerged on the web on 31st of October around afternoon. This paper was discussed in the technical forums. And now this paper was without a software. This paper introduced for the first time that between a buyer and between a seller, there can be a way out that there is no bank or there is no third party involved. Now this guy, few lines on this, he was Satoshi Nakamoto. Nobody knows who is he, where is he, and he remains a mysterious creator as on date. He, after uploading that paper in October 2009, also 2008, on another about few months down the lane on January, he released the software that pertained to the Bitcoin software paper that he had given the origination in October. Now, thereafter, he continued to collaborate with the developers on that domain that he created, bitcoin.org. Community was buzzing for something which was relatively new, and somebody was some decades have passed wherein technologists and researchers have tried to do this, but somehow it's a mysterious character who has not disclosed his name. He uploaded this paper, he uploaded the software, and somehow after about working on a year, in 2010, he handed over the control of source code and repository to Gavin Anderson, and thereafter he transferred the related domains, etc. And therefore, thereafter he stopped his involvement in the project and he vanished in 2010. That was the last time he was available as Satoshi Nakamoto on the web. So he still remains mysterious. News keeps coming. Now this clip was there last year in 2019 April. Now, John McAfee feels like Bitcoin creator Satoshi Nakamoto is a group of Indians, but all these are part of the news and clips. So, developing and growing on that single Bitcoin currency, which emerged in 2009, as on date, we have 2000 plus cryptocurrencies, and they all work differently. There are various variants to basically Bitcoin, and variants in various aspects in terms of architecture, in terms of how they work, and we'll come discuss in the coming presentation. Basic stats about the leading cryptocurrencies: Bitcoin, Ethereum, Ripple, Cardano, Stellar. All these are the leading the leading cryptocurrencies which are currently exchanging across the various stock exchanges, and they are wherever they are legal to say. And all these cryptocurrencies, they are basically variants of Bitcoin, but they all do things differently. It is not like in case I come to know exactly of how Bitcoin works, I'll have to apply myself again to understand the nitty-gritties of how other cryptocurrencies work. So just for info, 36 trillion is the total market of cryptocurrencies as on date. As on date, till yesterday, one Bitcoin was about $13,500. Reason this I am frequently asked, but I'll not be able to answer this. What is the reason that surges the Bitcoin price up and down? It remains a mystery. Approx number of transactions that keep happening in the world in last 24 hours, so about 3 lakhs per day. Bitcoin looks, etc. I'll not spend much time on this. Basically, this represents the address And we'll play with these addresses today in some demonstrations and simulations. So public key, private key, I'll not focus more on these because these concepts have been covered. So Bitcoin is often advertised as anonymous, but it is not anonymous actually, it is pseudonymous. So people can hide their entities behind a valid address as a public key. They will not be able to identify themselves as name, but all the addresses are the representative identities of all the users and all the transactions who are doing on the Bitcoin. So between anonymity and pseudonymity, the difference is pseudonymity is there is a public key address which is representing you, and anonymity is nobody will be able to even identify you, who you are, where you are, what is your public key or whatever. So pseudonymous is like just a nickname. In case I have a nickname or you have a nickname at home, so that's not my actual name, but that's my nickname. So it is pseudonymous. So Bitcoin by design is not designed to be anonymous. It is designed to be pseudonymous. So now we'll just start digging about what holds inside and what goes inside the Bitcoin blockchain from point of view of investigations behind the scenes. So this Dr. Ashok had covered what is blockchain. Basically has two words, various technologies, amalgamation, block and chain. Now he mentioned about Genesis block, but I'll just focus upon that. What Genesis is. So we have got these blocks. We have got these different blocks. All these blocks, they are linked to each other. They are cryptographically linked to each other. Genesis block, there is no difference between other blocks and Genesis, except for the fact that Genesis block is the first block. So Genesis block being the first block leads is the deep down the first block in the blockchain, and thereafter all the blocks which have come up, they keep getting linked to each other cryptographically. Each block is around 1 MB, 1.5 MB to 1.7 MBs. Also, maybe I have seen on Blockchain Explorer size is up to about 2.5 MB per block. So we'll see what goes on behind. So for now, to understand is all the blocks, they are cryptographically linked to each other in a sequence. They have got a definite size, and once these blocks are sealed, they are locked. They cannot be changed. They are so designed that that is why it is known as immutable. So once a transaction is indexed, so all the transactions which are happening, we'll go inside these details of what exactly is held inside a block. We'll do some internal forensics to these blocks. So what exactly happens is all the transactions are stored inside these blocks. And how are they stored? We'll see soon. So lots of cryptography, this traditional way of sharing documents, in case we say, how do we share documents? Basically, we can have a network, or we can have two people on email. They can have Google Drive, Google Docs, etc. So there are various ways and means. But the moment the number of users, they increase, that means in case the number increases to 1 million or maybe higher than 1 million, crores or billions, the bandwidth may not be able to take that much of load and the server crashes. So there we have got options: centralized, decentralized, distributed. So the ideal condition is, instead of having a centralized environment wherein a central control is there, the ideal expectation from a blockchain is that everyone, you and me or any other user, he has a local copy of the entire blockchain on his PC, and the internet takes care of the ensuring consistency. Every node, so whoever participates in the blockchain Bitcoin transactions, he has a copy of the entire blockchain on his PC. All the copies are identical, and all these copies are updated based on a global information. So this is just a assimilation point of view of one slide. So we have got 4 people here. We have got 4 people with different amounts in their kitty, 1,000 rupees each, A, B, C, D. So A transfers to B. Now this is one an example that I have given that I'm explaining you here, just from an understanding point of view of what exactly happens and how the distributed ledger grows. So here we have got 2 people, A and B. These guy A, He transfers rupees 200 to B. Now, I have mentioned here rupees, but otherwise you take it, these transactions are happening in form of value of a Bitcoin. So A transfers rupees 200 to B. The ledger gets updated. A transfers to B rupees 200. Now you see, now C and D were not part of this transaction. They are held at geographically apart locations, but the ledger was updated at their location also. Further to this, B transfers rupees 600 to D. Now, when this happens, B transfers to rupees 600. Now, in this transaction, there were two people, B and D, who were doing the transaction. But again, the ledger, the transaction has been updated at the node of A and C also. So, further to this, A attempts to transfer rupees 10,000 to D, but he is not holding that amount of money. So, that transaction is denied by the algorithm. So this is the basic overview, bird's eye view of how the ledger is building up. Now, this ledger at each node has got millions of transactions, has got a set of rules which defines the block, which defines the blockchain, how it works, like a global Excel sheet. So now distributed ledger. Now each word has got a heavy technology behind. Distributed ledger is a consensus. What consensus is, we'll discuss in little brief ahead. Is a consensus of replicated, shared, and synchronized digital data geographically spread across multiple sites and countries. Now, from a definition point of view, trying to explain a distributed ledger, it is as simple as these 2-3 lines. But there is a lot that goes behind, as we are all aware. As on date, the Bitcoin blockchain size is 327 GB. Now let me take you for a small I have got this virtual machine and I have got this complete Bitcoin blockchain which I have downloaded. Now this is the folder .bitcoin. So this is the basic structure that automatically builds up once you download the blockchain. Now I have got a folder by the name of blocks. Okay, first let me show you the size of the blockchain as on date. So it is 328 GB. Blocks 328 GB. What lies inside? We go to this directory and we simply list it, and there are a host of files. So these files, if you see, they are simple files, BLK, etc. We'll do some internal, what exactly lies inside these BLK files, we'll do ahead. But for the time being, you just see that the directory structure and the files and the basically the size. The main directory is blocks, and currently the size is 328 GB. So back to the presentation. So concept 2, hash. I'll not take much on this. Hashing, we all know various types of hash, and SHA-256 is one of the major algorithms and hashing algorithms that is used in Bitcoin, apart from many others. Okay, this is as simple as the triple IT hash. In case I take various hashes algorithms, MD5, SHA1, and in case I do a little change, in case I make the capital I change to small I, the entire hash changes, and that basically is the foundation, one of the very basic technologies which is used in the blockchain. Now Merkle tree was discussed by Dr. Ashok Kumar Das in the morning. So instead of the theory part, I'll show you some practicals or some simulations on this. Now we are very much aware of what a Merkle tree is. We basically collect hashes, and we take hashes of those hashes, and then we come to a root hash. So in case any kind of transaction we try to modify, so that complete hash changes and the root hash changes, and this hash, which is basically indexed inside a block, so this hash again changes. So that since we say that blockchain is immutable, the Bitcoin blockchain is immutable, this modification cannot be done till such time the consensus is more than 50%. So that we'll discuss later ahead. For the time being, Merkle tree is one of the building blocks of technologies which run the Bitcoin blockchain. Okay, now Merkle tree. Again, we'll go to this. I have a script known as Merkle. First of all, I'll show you what Merkle does. Now, this is a very simple script, not much happening inside, 10-20 lines. What here, the main important thing is that you see a chunk of characters lying down. All these 00B, A, etc., 91C, etc., these are all transaction hashes. Now, this particular script that I have made for a particular block. I'll show you. This is for hello.
Yes, sir.
Yeah, sorry, I got disconnected. I pressed the wrong button.
Good.
So
Yeah, yeah.
we were discussing about this blockchain explorer, and I have taken the block number 286819. Now I write this block number only here, and I press enter. The moment I press enter, now this what site I am working on is a blockchain explorer, and there are multiple variants to it. You can go to Bitcoin Explorer, Blockchain Explorer, and so many other things that you can use. So here I'm interested in the Bitcoin part. So we'll go to the Bitcoin blockchain, and here it shows that for my block 286819 that I'm currently speaking on, these are the identifying characteristics. So all those 99 transactions. So number of transactions here we see is 99 number of transactions in this block number 286819. So I have taken all these transactions, these 99 hashes, hash 00BEA. So we go here and all these transaction hashes, in case I'm sure you are able to connect now, all these hashes I have put in the script itself. And I simply run Python Merkle, and what do I get? I get the Merkle root hash. Now this Merkle root hash is 871714D. So this I have been able to make out from all the hashes of the transaction. And now this 8717 we'll see here. Now Merkle root at depicted on the open blockchain is same 8717. So the algorithm has been able to do this. All the block transactions, they have been compiled into one script, and I have calculated it in a separate script, and the blockchain, with this explorer part, they have basically made so many parameters out of this block, which are peculiar to it. We'll dive more into these. First, let us get over with the presentation part. So this was the Merkle root. So Merkle root is basically, now must be clear that all those transaction hashes that we compiled, hash of hash, and we get a final Merkle root. So any kind of modification that anybody attempts in that in those number of transaction, 99 transactions, so immediately the root hash that we calculated will be affected. Okay, now we have got try. Now try is a special tree that compactly, now this is another way of storing and searching database strings. Now apart from Merkle tree, we have got try, we have got Patricia trees, and then Patricia trees. Basically these are used in the Ethereum blockchain. Now instead of giving you the theory, first of all, this slide will make you a little clear of what exactly is. In case we have got these names, and we want to store them in our Patricia trees. So what the Patricia tree will do is, it will find R common. It will divide further ROM, UB. It will further divide R because ROM is common. So ROMAN. So Roman, then again till Roman is common. So it will again produce a new leaf ULUS. So this is basically the way how it works. It divides itself into more number of leaves having a common kind of parent branch. So again, we'll see this in a demo. So the best part is that everything in the domain, blockchain especially, is open source. There is no need to actually, in case somebody has got a keen interest, everything is open. So first of all, we'll see about the try. Now, if I insert here, now it produces ANUPAM. Each alphabet is is depicted separately. Now, in case I have Anu or something else, some other name, so it will work like ANUP is common, and thereafter it will create a new branch. Further to this, in case I create a new thing like IIIT and I try inserting it here, so it will altogether start a new branch. I and T. It will try to find out. So basically, this is just one way of searching the ways. So apart from try, we have got these Patricia trees also. This also will see. So here we have got individual alphabets. Alphabets. Where is this radix? So there is one radix tree also. So again, I say Anupam. So what it will do is it will create all this. Now I say Anil. It will insert Anil. How? It has found AN common between Anupam and Anil. If I say Amit, I add Amit to it, so A will be common. So again, this is just another way of the trees working together. We'll go back here. Now we have seen Merkle tree, we have gone Patricia trees. Now Ethereum uses Merkle Patricia trees. They basically combine these two technologies and the name, the indexing, and the hash part. So we get clear with the trees part. Now we come to, okay, this is relatively easy. Symmetric and asymmetric encryption, not much time on this. Yes, the interesting part. Bitcoin internals behind a simple address. Now, this is a very interesting part. Now, whenever we speak about a transaction, what does the user hold? A user holds a public key. A user holds a private key. So, suppose we have got a private key here. So, from a private key, I will be able to derive the public key. From a public key, I'll not be able to derive private key, but it is a well-known thing that from a private key, I'll be able to derive the public key. From this public key, I will take a hex of SHA-256 and I will get some output string as visible on the screen. Now, after I take this hex of SHA-256 of this string, I will take a RIPEMD160 hash of the above output. So this string again is a RIPEMD hash. Further to this, I add, there are various ways and various rules to what we are actually trying to find is the Bitcoin address. So we had a private key, we derived the public key, thereafter whole ways of for performing various hashes. We added versions to it, we added, we repeated the hashes, we conducted RIPMD hashes. Ultimately, after doing a set of calculations, we find at the end a Bitcoin address 16UWLL. So after going through all these steps, one single Bitcoin address is derived. Now, this again, this complete thing I've shown you on a slide method, but here there is a way. You go to this website. I'll be sharing all these links in the presentation. Subsequently, I'll share in the forum. So we have got a website. We generate a random key, and since I have calculated it all manually, I took a lot of time. But here, in case I go to this website just from a check point of view of what are we doing or how the things are, or in case we just want to test ourselves, starting from a private key to public key and deriving everything manual. So this is one side wherein we'll be able to go through all these steps and check finally the Bitcoin address. So this is one derivation of Bitcoin address, that all these steps go together in sequence once the user attempts to do a transaction via his wallet. We'll discuss wallets all again. So let's just revise ECC also. Although it has been covered, I'll not go into that much of detail like Dr. Ashok had come. So linear equations, we are aware, y is equal to mx plus c, a straight line, 10 plus 2 mathematics. Quadratic equation, as simple as that, equation takes shape. Cubic equation, in case we go ahead from linear to quadratic to cubic equations, the graph somehow moves around this. Elliptic curve equation, the thing that we'll be discussing, and the thing which Bitcoin blockchain is based in, is y square is equal to x cube plus ax plus b. So this is the elliptic curve equation. So the interesting thing is y square is on the left side. So that is why the symmetry here on the graph we see around the x-axis. So what is special about the Bitcoin and the elliptical curve equation? Now, elliptical curve equation is the cryptography behind. Okay, so now sec P256K1, it refers to the parameters of elliptical curve. Now, elliptic curve, like I had shown you in the equation, y square is equal to x cube plus ax plus c. Now, a, x, and b, these are the variables. So these variables can be given anything, and we'll get to see various kinds of elliptical curves. Like I'll show you one here. Before it happens, actually, okay. Now here I have, this is again an online tool wherein I have a Bitcoin equation. Now in Bitcoin, y square is equal to x cube plus ax plus b. Here we have got a is equal to 0 and b is equal to 7. Now this is the special case about the sec 256K1 thing that I was talking about, wherein it has got these specific parameters, b is equal to 7 and a is equal to 0. So this is the kind of graph that we see on the screen. We can tweak, we can play with it. So like in the morning, Dr. Gupta had mentioned that the special thing is wherever in the elliptical curve, elliptical graph, wherever we attempt to throw a line from point A to point B, it will extend further and move to point Q. That will be the third point. Again, that can get reflected here on the other side, and we will be able to do so many things like scalar multiplication, scalar addition, scalar subtraction, and these are all happening in a definite field set. So okay, now this I have already given you in the a is equal to 0 and b is equal to 7 part. So the final equation of Bitcoin that moves for the ECC cryptographic part is y square is equal to x cube plus 7. Now finite field. Now just one slide on what finite field is, then I'll show you some calculations. Finite set is a field. That means wherein multiplication, addition, subtraction, and division are defined and satisfy the rules of arithmetic inside that finite set only. From the definition, you may not be able to assimilate that much. Now here on the slide, I have got a finite set of 19 elements. So I have got F19. Now I will attempt, now these 11, 6, 17, 6, 8, 14, these are all numbers which are less than 19. And I will do definite addition, definite subtraction on these numbers, wherein I will be able to get the answers. Now it is not the peculiar mathematics that we do. 11 plus 6 is 17. 17 minus 6 is 11. 8 plus 14 is 22. But 8 plus 14 is 22. That means it goes way ahead of 19. 4 minus 12, again, it is minus 8. But is it inside that 0 to 18? No. Now the 19 element says 0 to 18. So everything has to be less than 18. Sorry, 19. So 11 plus 6 will, in case we do the definite addition, it will be 17% 19 mod, we'll get 17. 17, okay, 17 minus 6 is equal to 11 mod 19, that will be 11. So 17 and 11 have actually come as per the expectation. 11 plus 6 in normal mathematics is also, but this interesting thing is 8 plus 14. 8 plus 14 is 22, but we take a modulo of it and we get 3. 4 minus 12 is minus 8, and we take a modulo again and we get 11. Similarly for multiplication, 2 into 4 is 8. Okay, 7 into 3 is 21, but 21 we take the mod part. 15 into 4, 60. Now I'll not focus much on this of how are we doing this, but these are the basic foundations on which the complete Bitcoin calculations cryptography is basically based on. And there is nothing very complex about it. The moment you come to know of what scalar multiplication, scalar finite field addition, subtraction, divisions, what are these? Now 2 by 3 in the normal forums, in the normal calculations, what will be 2 by 3? But in 2 by 3 will be a fraction, or we will be able to convert it into a suitable decimal part. But here 2 by 3 will be, as per the Fermat's little theorem, we will have to take this formula into the calculations, and we get 2 by 3 is equal to 7. Now this is very vague. 3 by 15 is 4. Now this is very vague for those who are not aware of what finite fields are, what finite field mathematics is all about, and the normal regular mathematics is automatically going to clash. But the thing is, whatever whatever algebra is behind the normal mathematics, 2 plus 1 and 3 plus 4 is equal to 7, and 10 plus 9 is equal to 19. This all, the rules plus addition, subtraction, multiplication are exactly applicable to the definite field, to the finite field mathematics also. So this slide basically shows the number of addresses on a ECC that we can calculate up to, we can define up to. So this defines 1.46 into 10 to the power 48 Bitcoin addresses which are possible. Now 1.46 into 10 to the power 48 is the total Bitcoin addresses, and today the world population, in case we take it broadly, around 7.5 billion. So that gives every person on earth 2.05 into 10 to the power 38 different addresses. So here comes the crime part. The criminals, the cyber crimes, the malicious elements who will be interested to do any kind of calculations will never use the same address. They have the world of addresses for them to explore, exploit, and do transactions. They will not try to do all the transactions from the same address. So till now, what we have seen is basically everything is all about maths. We are talking about cryptography. We are talking about mathematical guarantees about so many messages. Networks is, again, instead of client server, not much. We use peer-to-peer. Okay. Now this is a very interesting concept. Fifth, that is the proof of work now that we are coming to. E-currency has been attempted in past. Of course, we said double spending had been attempted, that it gets removed, the double spending problem, but somehow only Bitcoin was able to remove that thing, and double spending otherwise is defined as a potential flaw in a digital cash scheme. So here we come to the consensus part. Now consensus part is a phenomenal domain in itself. Here we'll discuss today about the proof of work, how proof of work happens, what exactly goes behind. Otherwise, from per se, the definition consensus is basically defined as a general agreement. You and me and the community agrees. It is as simple as that. In case I transfer some rupees to somebody, so one will credit and the other will debit. So one will lose and the other will gain. So every clean transaction only has to be recorded on the Bitcoin public ledger. So that's thing is completely taken care by the consensus algorithm. It ensures that no malicious transactions nor changes can be made on the blockchain itself. Okay, these are the consensus types. And now here what you see on the screen are just 8 I have shown just from a basic awareness point of view. There are, as on date, what I have read, and I have written a survey paper also, I have taken into consideration about 52 consensus which are currently existing. Various consensus, 52 to the tune, basically what I am aware and I have read about a little. And all these consensus basically are variants of each other. Some are absolutely different and they have different working internals of how they work. So all these consensus, of all the consensus, now we'll be considering and discussing on the proof of work. What proof of work? Now again, first we'll take the theory part and then we'll do some practical to basically understand of what proof of work is. Now proof of work is a piece of data which is difficult to produce but easy for others to verify and which satisfies certain requirements. Now this becomes the definition. Now definition as such, there's little to assimilate. Okay, how does it make a difference? What is difficult to produce? You may not be able to basically make out of what is this, but in case you see here, Bitcoin uses the hash cash proof of system. This was the same concept that was used that was introduced in the history slides of Bitcoin that I had mentioned earlier. So here we discuss Byzantine general problem, reaching a consensus, how a consensus is reached in proof of work. Now, instead of explaining it in a very complex mathematical way, I have made out a way out that I can explain it to you in a very simple manner. Now, it is up to my way that how far I am successful in explaining you. So I'm trying to explain you the same in a story form for easy assimilation. So we have got these two armies and we have got a fort in between. There is an enemy fort in between and we have got army 1 and we have got army 2. So in the old days, while these army 1 and army 2 were geographically located apart with a fort in the center, they wanted to attack this fort. Now to attack this fort, the condition is that they have to attack it at the same time. They have to attack it on the same day. It should not happen that in case army 1 attacks on Monday and army 2 attacks on Tuesday. So they have to basically attack on the same day and the same time. So what do they do? There is a consensus required. What day and what time to attack? So ideal conditions are that army 1 or army 2, in this case I have taken as army 1, they send a messenger from 1 to 2. It goes, gives the message to army 2 that we'll attack on Monday and it comes back. Now this is a very ideal situation. The thing is, both generals agree as per the exchange of messages. So we are basically dependent on the messenger that he has conveyed the right message. But if the messenger is compromised, if the messenger is intercepted by the fort guys, there are chances that he gives out that army 1 is giving the message that attack Monday, and in the middle of the fort compromises the messenger and he changes the message, attack Tuesday. And the army 2 attacks on Tuesday and army 1 attacks on Monday, and it is a complete failure and they both lose. Now there is a need for a secure communication. Army 1 and army 2, they have to secure the communication. Instead of plain text attack Monday or attack Tuesday, they have to secure it. Now how they do it? How do they ensure that the guaranteed unaltered message is passed? Now in the domain of IT, it has been proved wide, many FLP papers, in case you might have read or heard of them, that basically there is no true solution. Not to say that computers cannot communicate with each other reliably, but yes, there is 100% certainty is not possible. And best efforts simply make the communication very, very reliable, but never foolproof. So proof of work is the answer. So what does it do? Now attack Monday, we take a hash out of it. Now how difficult is to take a hash of anything? It is just a click of a button. You type the message and you get the hash. But we place a condition here that there has to be a prefix to it. Whatever hash is generated in the message, like attack Monday, and we get a hash, it has to be prefixed by a certain number of zeros. For example, here we have taken a number of zeros to be prefixed as 6 or 7, I think. So we have taken 7 zeros to be prefixed. So attack Monday, we take the hash, and the desirable thing is the desired output should be anything, any hash, any string of numbers, but it should be prefixed by 7 zeros. Now this is the condition. Now how will we do it? Now we introduce the concept of nonce. Now, from Google, in case you find out what is nonce, basically the word originated from nonsense. It does not make any sense. So that is basically shortened to nonce. So attack Monday, in case we add this nonce. So attack Monday का जो hash आया हमारे पास, in case we add this nonce 6158 to it, we will get a hash output which is prefixed by so many number of zeros as desired. Now this calculation of nonce, this is not a very easy thing. So Army 1 has taken computational effort to find out this nonce. Now there is no formula to it. You have to exactly do permutations combination. Otherwise, in the simple manner, you trying to keep taking hash, you have to just depend on various lucks and various factors that you finally get a number prefixed by 7 zeros. So in this case, they find a hash 61584 and they give it to the messenger. Nonce cannot be calculated by formula, it can only be guessed. Now it is difficult to calculate, easy to verify. What does this mean? It is difficult to calculate this number. Now this is difficult to calculate, but it is very easy to verify. In case I give the nonce, and in case I give the hash, so hash plus nonce will give me this. So verification can be easily done, but calculation is the difficult part. So we move ahead. The messenger goes again, and he comes back again. Now here, even if the enemy fort plans to change, he will have to come out with a nonce. In case he says attack Tuesday, now he'll have to apply himself to do the computational part and find out what nonce will it take to make a hash out of attack Tuesday, which is prefixed by 7 zeros. So that computational part is generally taken, he will not be able to reach, and the communication is secured between Army 1 and Army 2. But the story does not end here. When Army 1 has taken a computer and it has been able to take computational, it has been able to make the computational guesses and calculate the nonce. The town, the fort that we are talking about, they now come to know that this is the way that they are doing the jiggery pokery. So we'll also buy a giant computer. We'll buy a supercomputer. So whenever they catch a messenger, they now have the computing resources to modify the nonce so that the 7 zeros property is satisfied. So now the fort is ready with that much of computing power. To add to the difficulty, now the requirement, Army 1 said, now they are also having a computational thing, and they can also find out a nonce. So we will add more computing requirements. So instead of 7 zeros, we'll add the difficulty level, because the more the number of zeros, the more is the difficult part to find the nonce. So what's the connect? Now, till now, what is the whatever story I have explained here? Now, what is the connect between that consensus and what these kings are fighting for? Now, what is the connection? Now, let's say that there is not 2 generals, 1 city, but let it be a number of generals and a number of cities. Idea works best when we have many cities. Now, replicate that scenario of 2 armies and 1 city. Now replicate that into a number of armies and into a number of cities, all doing that same thing. Now Satoshi's Nakamoto idea was the generals all combine their messages into a single giant message, that is a block, now which gets but a single nonce at the end. So all these armies, they combine their message into one block and they find a single nonce, and whatever generals and whatever armies they are fighting against each other, we attack at noon, we attack at dawn, we attack at dusk, whatever, these are kind of transactions which are simulated or which is given for understanding here. The new policy is that we need 16 zeros instead of only 7. So difficulty level has increased. So the hash of the entire message comes out to something like, as seen on the screen, we have got a number of zeros here, 16 zeros, and then the hash with a nonce given. So we are increasing the difficulty level. So all generals do their computational part, their combined efforts. Now they have got a nonce, working nonce, which has got peculiar characteristics that when added to the transaction message, they will get a hash which is prefixed by those number of zeros. So now I'm sure when if you are able to assimilate here, so there will be a question that what if all the cities they bought supercomputers and did the same things the general team did and team up to find a nonce? Yes, it is possible. But in context of blockchain, basically it is known as the 51% attack. That means if the cities have as much or more computing power as all the armies combined, that much of computing power as all the armies combined. Of course, it is not impossible to defeat this, but basically the general idea is it is very, very hard. Now, when we speak about this scenario of a possibility like this is possible, yes, it has happened. In 2014, a 51% attack was there. Now, what happened was a mining company, mining pool Gash.io, it controlled 51% of the processing power. Now, it was able to briefly gain enough processing power to theoretically destroy the currency. Now, this was again made known and it was made aware that this is possible. But shortly after the threshold was breached, some members of the mining pool pulled out their computing power from the group, averting a catastrophe. So there was a moment when the computational power was good enough to break the nonce. So the mining pool ghash.io, so it briefly exceeded 50% of the Bitcoin networking computing power in July 2014, leading the pool to a voluntary commit to reducing its share of the network. So they had to voluntarily come down to 40%, so that and they gave a statement basically that in the future we'll take care of this. So Krypton and Shift, two blockchains based on Ethereum. So again, similar attacks had happened, 51% attacks in August 2016. So these possibilities are there. 51% attack, the possibilities are there that a blockchain can be modified or can be attacked in that manner, but that would need that much amount of computing power. A single person, no. There may be a community which decides at global level with so much of computing power, yes, then it is possible. So we'll just go to one website. If you have not been ever, it will be a good thing to assimilate here. Here is blockchain demo. Now what I'm going to do here is we have got blocks. We have got blocks and we'll type some messages here. Suppose these green boxes that you see, 1, 2, 3, this is a complete chain. So consider them that this is one single block. I type in some message here. The moment I type the message here, these can be taken as transactions. It can be a transaction, it can be a numeric value, or it can be anything. So for this part, I mine it. Now what mining is, we'll discuss it at length a little later. But for the time is that mining means I'm trying to find that nonce. I'm trying to find a mathematical puzzle which will prefix the hash of this data that I have typed with a number of zeros. In this case, I think the number of zeros is 4. So I press the button mine, and within few seconds, it will give me a hash which is prefixed by a certain number of zeros. Yes, I have got it. And now I've got a fresh nonce also. In case you have not noticed, earlier the nonce was something else, and now the nonce is something else. Now, automatically, when in the beginning I said the blocks are cryptographically related to each other, here, so here in the second block, we have the hash of first block. So we have got the hash here 000009370. So this hash is indexed here. Now I do certain transactions here again. I punch in some data here again, and I again now keep in mind here, just keep a watch that the nonce 35230 here and the hash here. The moment I press mine, I try finding that hash with the nonce. So the nonce changes. Now I am doing this on a desktop. I have got a 16 GB RAM and I have got i5 processor, and this is a desktop level calculation with a minuscule effort, but from a assimilation point of view of what basically happens. Similarly, I go to the third block. The hash of second block is now seen in the third block, F89, F89. You see here. Again, I punch in some transactions here. These transactions, again, I mine, and the moment I mine, a fresh nonce will be there and the fresh hash will be there. So now for a assimilation, we have got three blocks here. Suppose for an understanding, we end this blockchain. Our blockchain has got three blocks only for understanding. Now, in case I do any kind of modification anywhere, suppose I do a simple 4, I am replacing it with 7, or I simply delete it, the complete blockchain becomes red. Till such time it is reverted back to the original data, the blockchain becomes red, remains red. In case it is modified, it becomes red. So basically this is just one sample. Another sample, this dummy data that I have typed here is basically dummy data. Now here it is more or less something similar to what exactly is stored against. Okay, now in blockchain, in Bitcoin blockchain, there is no Darcy or no Bingley, no Elizabeth, no names are there, but there are public keys. Now these public keys, I'll be showing it at a later date. For now, again, it is the same thing. Instead of data that I punched in there, I have got figures here from so and so to Bingley, from here to here, from here to here, and these are the number of dollars that are being transacted. Now I do a modification here. I say it is $67. I mine it again, and the cycle again starts in the same manner. Again, it will mine. It will give a fresh hash. It will change the nonce. So from 139358, it will take some time. So I'll wait. It is taking time. So it has given me a fresh nonce, and I have got a fresh hash, which is prefixed by 4 zeros. Now this again, the same thing continues as it happened. So from a understanding, this is blockchain when we say cryptographically linked to each other. Now we discuss mining. Now mining is the process by which a new Bitcoin is added to the money supply. Now there was a question in the morning wherein one participant had asked, what do the miner actually gain? Why should he mine? So we'll come to that here in the next few slides. For the timing, just read the slides. Mining is the process by which new Bitcoin is added to the money supply. Mining serves to secure the Bitcoin system against fraudulent transactions. Miners provide processing power. So whatever nonce that we were trying to find, what we were trying to understand, compute, this is all being done by mining. Miners validate new transactions and record them on global ledger. I'm sure there will be few questions that will be emerging in your mind. Either we can take it at the end of the webinar, or maybe you can post it in the chat. I'll see it during the break that will follow after about 10 minutes. So a new block contained transactions that occurred since the last block is mined every 10 minutes. So just I'll take you here to the virtual machine. Now there I'll give you a blockchain info. You just write down the number. Now this is a blockchain info that this will discuss in detail at length. But for the timing, you just write down, anybody of you or any one of you who is interested to know. Now this is the block. Now when I say this is a live blockchain, when I say that I have downloaded the complete Bitcoin blockchain and this is live, this is getting real time updated. So here from this command Bitcoin CLI get blockchain info, I get these parameters from the live blockchain. Now it says 655363. So I'll just write it down, 655363. Now this is the block. Now coming back to the presentation, I say a block is mined every 10 minutes. So ideally every 10 minutes, whenever we will see this block after about 10 minutes, 20 minutes, 30 minutes, there will be additions to it. That means those number of new blocks have added to it. So transactions that become part of a block are not treated as confirmed, and the process of new coin generation is called mining because the reward is designed. Now, reward again, I'll explain as the somebody had asked in the morning what reward is and what are they doing with it. So the amount of newly created Bitcoin a miner can add to a block. Now this is inbuilt to the algorithm that every 4 years, or every 210,000 blocks, after every number of these blocks, the reward will be halved. That means in 2009, when the Bitcoin has just started, the first block, the Genesis block we discussed, from first to 210,000, the first 210,000 blocks, anytime a miner was able to mine one block, he used to get 50 Bitcoins per block in January. After 4 years, that is in November 2012, now this 2000 in 2012, 50 was halved to 25. So mathematically, what should we standing today? It will again halve to 12.5 in 2016. So that is already done. So from 50 to 25 to 12.5. As on date in I think April or May, sometime in April or May 2020, the reward has halved to 6.25 Bitcoins. So we all started with around 50 Bitcoins. And then we are actually somewhere here, 2020, per block. The miner, why is he mining? Why is he putting in so much of effort for mining? So basically, he is looking for all these rewards, 6.25 Bitcoins per block. In case you are successful at mining a block, finding that nonce, you will be awarded automatically by the algorithm 6.25 Bitcoins in your account. So this is likely to go till 2030 and beyond. So basically, another interesting part is 2140. That is around 120 years from now. The last Bitcoin will be mined. There are around 21 million Bitcoins to be mined. Either we can discuss it later, or in case time permits, I'll discuss in between. So measure of a miner's performance. What are miners fighting for? They are fighting for the hash rates. As I said, there is no formula to calculate the nonce. You have to basically do permutations, combinations at a very fast speed, very high speed, to find that nonce value. And the higher the hash rate, the higher the speed that a computing miner has, the higher the chances that he has more chances. So in 2009, when the difficulty level of finding that nonce, of prefixing those by zeros, etc., it was being achieved at a level of a CPU in 2010-11. So had you been mining in 2010, the Bitcoin, had you known there is something known as Bitcoin, you would have basically been a millionaire or billionaire by now, because that time a CPU could mine. Thereafter, 2011 onwards till 2015, GPUs and free field programmable graphical arrays, they came. And after 2015, all these failed basically because of the higher difficulty level rising. So they converted to ASIC, application specific integrated circuit. Now what ASICs are, of course I've given you the full form, but what do they look like, etc., we'll see in little detail. So basically the hash rates, as on date, 60 exahashes per second. This is the kind of specs that a miner should have. So interplay of basically 4 processes: independent verification, aggregation, verification and selection of new blocks. This is all being attained by the miners. The hash rate denominations, basically just general knowledge, what hexahashes means, what quadrillion hashes means, and what number of hashes they are actually finding. So overall concepts we are done here. In the post lunch, now it is about 15:40, so we'll take about 10 minutes break. We'll see how much time is been given by Dr. Lakshmi. So,
yes, sir.
So we take a break for about whatever number.
Actually, 15 minutes break is scheduled,
okay.
sir.
Okay, so we'll get back at 1600 hours.
Yeah.
Okay.
Yes, 4 o'clock.
Okay. Thank you.
So quickly, 2 minutes time.